Alright, here we have section 3.3, Properties of Logarithms, and the first property we are going to talk about is the change of base formula. You would use the change of base formula anytime you have a base other than 10 or e, because we have the log base 10 buttons on the calculator, the log base e button, also known as the ln. Those buttons are on the calculator. So if I ever have the log of something that is no longer base a, I could rewrite it essentially either using log base 10 here, alright, obviously moving the x to the top, moving the a to the bottom. If I didn't want to use the log base 10 button on my calculator, I could do this same idea by using the ln. So right here, you have this is the change of base formula. You could change any log to a division of any other two logs, but most commonly you use it for log base 10 or ln are the times we would use it. So, real quick, we'll do one calculator example. If you have to do log base 24, well, the easy way to type this into your calculator is log of 25 divided by the log of 4. Another way to type it into your calculator would be the ln of 25 divided by the ln of 4. So either one, you'll see they come out to be the exact same answer. So here's my calculator. I could type in the log of 25 divided by the log of 4. That answer, and you're going to notice if I did it with the ln of 25 divided by the ln of 4, also going to get the same exact answer both times. All right, and you can round that to whatever the directions require, any necessary decimal place. Okay, here we have some log properties that you've probably seen in Algebra 2. If you have a product of logs, well, you can write any product of logs as a sum of logs by just keeping the base the same and rewriting it. So if you're going from in this direction, that'd be called an expansion. And if you're taking a longer sum of two logs and writing it as a product, that's like a contraction or a condensing are the two words that they use. Okay, if it works for multiplication, it also works for division. If you have a division of a log of a division problem, that's the same as writing it as a subtraction of those two logs. And again, if you have a subtraction of two logs, you could change it to one division problem. And the last, and this is probably the most forgotten about rule, if you have a log of something raised to the n, you can move this something out in front, or you can move the something out in front as to being an exponent. That becomes very useful with logs. All right. So here we'll practice using a couple of these properties. Log base 6, write it in terms of ln2 and ln3. So I hope you would agree that ln6 is the same as ln of 2 times 3. 2 times 3. And because this is a product, I could write it as an addition. Log base 6 is equal to the ln of 2 plus the ln of 3. Here we have another division. We can use using only log base 2 and log base 3. First off, I could write this as the ln of 2 minus the ln of 27. That's because it's a division problem. So I can keep this part exactly the same. I'm not going to change that. I like the ln of 2. It's the 27 that I got to think of. Well, that's 3 times 3 times 3. So I could write that as minus the ln of 3 to the third, and last but not least, because this is an exponent, I can write it in front, so ln of 2 minus 3 ln 3 will be your final answer. Alright, here we have a little proof. We are going to prove that the opposite of the log of 1/100th is the same as log of 100. So when I start with a proof, I usually forget about this part on the end. That's where I want to end. What I want to do is I want to manipulate the left-hand side and hope that I can eventually end up with something equal to the right-hand side. So on the left here, I notice I have -1 log of 1/100th. Because I have a -1 in front, there's another place I could rewrite that. I could rewrite this right up top here as an exponent, and I could write this as the log of 1/100th raised to the -1. Now, I could also calculate 1/100th raised to the -1, and I hope you remember that when you're raising to the -1, it's essentially taking a reciprocal. So this here, getting rid of this negative exponent, this is really the log of 100. So this is a short 3 or 4 step proof. All right, and last but not least, actually 2 more problems, I'm sorry. We're going to do another few just expansions. Here it's still the same expansion, just maybe a little longer. We are going to be looking at log base 4 of 5 plus log base 4 of x to the 3rd plus log base 4 of y. And there's really only one, so that's using that expansion rule. There's only one other rule I can use to simplify here. I can take this 3, I can move it in front, so my final answer, log base 4 of 5 plus 3 log base 4 of x plus log base 4 of y. So that's an expansion, and we will close by looking at a couple condensing problems. So the idea with condensing is the first thing you're going to have to do is take these numbers that are out in front and move them into exponents. And we would write this as the log. Now I could write x to the 1/2, but there's another way to write x to the 1/2. I hope you recognize x to the 1/2 is the same as square root of x plus the log x plus x plus a to the 3rd. Now you got to be careful with, I cannot separate these two. That's one piece that needs to stay together, even though it's an addition. I cannot separate it because it's got the exponent on the outside. What I can do is that because this is an addition, I could write this as the log of the square root of x, because this addition is here, and it's the same base with both of these logarithms. I could write this as x plus a raised to the 3rd. So that would be condensed down to just one single logarithm. Same thing here. I can take this 2, I can write it as an exponent. That is the ln of x plus 2 squared minus the ln of x. And again, the only simplification I can do, subtraction is going to mean division. So this is the ln of x plus 2 squared over x. All right, last one. So what I see here is first, if I work on the inside first, what I can do is I can write that as log base 2 of x times x minus 4 all times 1/3. The last step here would be to take the 1/3 that is out in front and actually move it to as an exponent. Now, log base 2, I could write it as x squared minus 4x. That would be fine. All raised to the 1/3. That's one way to write it. Another way to write this answer would be log base 2, the cube root. And you could have actually left it factored, so there'd be nothing wrong with someone who said this. There's no real right or wrong answer. There's several ways to write this answer. But please bring any questions you have with you to class tomorrow. We will see you then.